to, that's not how you do it.
I know.
You gotta go like this.
Big difference.
No, it's not. You got it level?
Now it is.
Okay. Now go ahead and mark it.
There's too many arms over here.
Okay.
Can I get out of the way?
Alright. And the reason you have to do this level on their head is because you can get a measurement there. Alright, let's go ahead and just do Matthews because we're going to do all the people in the class later on, but just for the camera we'll just demonstrate Matthew. So step over here to the whiteboard, and now we're going to get his wingspan. Now when you're doing measurement, you have to be consistent. So we have this middle edge here. He's going to put his fingertip on there. We got to do a 1 meter mark first because we assume his wingspan is greater than 1 meter. Bring the level.
I got it.
And for accuracy, we got to make sure that this meter stick is level.
Yeah.
Now we're going to go ahead and make a vertical mark because the people are going to have their wings at different heights of their arms. So that's why you have to make a vertical mark there for 1 meter. Alright, go ahead, Matthew. He tries to flatten out, give as much wingspan as possible. We need a recorder up there. Go ahead, Aubrey, you go up there and record. You have another pen up there? Let's see. Yeah, here's some pens. Make sure that they're fresh. Okay, so what'd you get on his wingspan there? You're measuring it right now? So they're going to have to add to the 1 meter, whatever they get right here. And we're going to use units of 178.5 centimeters. Alright. Let's go ahead and get...
Ready to measure my height?
Yeah, let's get his wingspan, then we'll go over there, we'll get both of your heights. We'll do mine too. Alright, and this is Jackson Hobson. Yeah, you might be stretched out here today. And actually, we should be checking to make sure that this meter stick is level, because you can get a slight variation. Looks like 181.6 for 7.
Oh yeah.
181.7. Okay. All right. Since I have the fabled monkey arms, I'll go ahead and see what I can get. Okay. During my amateur basketball career, that came in handy. Okay, you got it over there?
Right there.
Okay, I got one. Yeah, level it off.
Put that on your right color.
Okay,
The one.
okay.
Right there.
195.6 centimeters. Okay, now we got to get the height. When I was teaching at a bigger high school, a 5A school, we got as many as, I think it was close to 1,800 data points. So the more data points you get, the more accurate it will be
We got it over?
with your speculation of what the wingspan to height ratio should be for
A level you want.
an average person. Okay, and we're not using feet and inches because you have to use a bunch of fractions that makes it more complicated. The metric system is easier to work with. Okay. Alright, we got the recorder up there, Aubrey, so now we're going to record these measurements here. We should check this for level too. We're trying to be as accurate as possible. Where's the
You
bubble?
really need to go reference.
Okay. Okay, I see it now. Couldn't even see the
Right there.
bubble at first. Alright, I got, this is Matt at 184.
Even?
Yeah. And Mr. Keller, ready?
180.
182. And you got to get your eyes level with what you're reading, because otherwise you're going to get an inaccurate measurement.
Jackson.
178.6. Okay, so we got the calculator up there, I think. Let's see. So now we got to get the ratio. Okay, you're going to divide those? Aubrey? Let's just divide these three, and then we're going to show them what, we'll plot these three, and then let's see what we got with just 3 data points.
178.5 divided by 184.
Give it to about 4 or 5 decimal places.
0.9701.
Okay.
And then 181.7 divided by 178.6. 1.0174. 0174. And then 195.6 divided by 182. 1.0747.
Okay, I've been doing this for over 20 years, and the record for the longest time, I had the greatest wingspan-to-height ratio I ever recorded. But then all of a sudden, the same school year, back in the 1990s, late 1990s, I got a kid that was 1.08, and then astoundingly, I got a guy that was 1.10 something. So that guy had some extremely long arms. Okay, now, if I could step in there for a minute, Aubrey, we'll go ahead and plot these. I should have had this ready, but I don't have it ready. Alright, so, let's see. Give yourself like a little bit of a border. How much time are we taking up so far?
Almost 10 minutes.
Okay. Alright. When we had the hundreds of data points, this thing was like literally covered with dots. We had to go to a bigger we went to a sheet of paper. It was like an expanded graph. Okay, so I think I'm going to do the wingspan. I'm going to start at 150 down here. And then I'll make this 160. I think this will work. 170, 180, 190, and 200. And this is the wingspan in centimeters. And then down here we have the height in centimeters. And start at 150 again. So this will be 160. This would be 170, 180, 190, and 200. So on the first one there, with Matt, his was 178.5. This would be 175. I'm going to approximate it about right in here. And then his height was 184. So that's going to be about right in here. And then Jackson was, the wingspan was 181.7. So for graphing purposes, I'm just going to call that 182. And then I'm going to come across to 178. Would be about right in here. Of course, we only have 3 data points here. And I got 195.6 up here. And then the height is 182. See, that's about right in here somewhere. So you're not going to be able to tell much from that, but what we found in the past, and I should have saved some of those graphs, was that when you do your best fit curve, obviously we have to have more than 3 data points here, but when you do the best fit curve, the line comes out with a slope that's real close to 1. So my suggestion, that's all the data points we have here today. If you get somebody with extremely long arms compared to their height, then those are going to be what we call outliers.